Hello students, in this video I'm going to cover chapter number 5 examples for you, and the chapter is work, energy. So before going to start this lesson, I'm going to explain some basics for you so that you can relate them and you can focus on the topic. So in this first step, what you need to understand, work is equals to energy. Work is equals to energy, and in this topic we are going to learn about number of energies. The first energy is kinetic energy, which is equals to half m vf square minus vi square. Vf is your final velocity, Vi is your initial velocity. Second, we are going to learn about potential energy, which is equals to mgh. Third is equals to your spring energy. Spring energy, which is equals to your half kx square, where k is your spring constant. Okay, fine. That is the work and energy. Second thing, what you need to understand, that is about the force. Okay, force under horizontal. Horizontal means along the x axis. So F is equals to ma, where m is the mass, a is the acceleration, and acceleration is vf minus vi divided by time. Clear? These are the very simple things you need to focus. So this is for your horizontal. Now for your vertical, if the body is going up or down or along the y axis, so what you need to understand, F is equals to m times g. So g is your gravity. There are the two cases, if body is going up or if the body is going down. If body is going up, negative, going down is positive. Third case is for spring, in cases of spring. So here is your F is equals to minus K times X. K is your spring constant, and X is your change. Let's say XF minus XI. It is compression or elongation. Fine. Third thing, which is your power. So power P is equals to work done over time, which is equals to energy over time. In the energy, you can say kinetic energy over time, you can say potential energy over a time, you can say spring energy over a time, or the last formula is force times velocity. These all are the equations for your power. Depending upon that, what is the situation. Let's say if the body is in motion, so we will use kinetic energy. If there is a word called position, we will use potential energy. If velocity is given and with force, we will use Fv. Okay, these are the things. Now let's move to the questions. So we have the question number 1. What the question is telling us, so try to understand. A crystal vase mass is given, so mass is 2.4 kg is dropped. Okay, this is something which you need to understand. If something is dropped from a particular height, so initial velocity is 0. Clear? And this is the body is at maximum height. The body is at maximum height. Maximum height means potential energy is mgh and the kinetic energy is 0. Clear? This is, let's say this is your position A, this is your position B. Dropped from a height. Okay, height is given, so height is 1.3 meter. Falls to the floor. Floor means base. This is your base. So at the base, can I say height is 0 and Vf is your maximum. Velocity is maximum. So can I say potential energy is 0 and kinetic energy is maximum. Clear? Okay. What is the kinetic energy? We need to find out kinetic energy. So guys, the basic thing what we need to understand, total energy always remains the same. Total energy at A is equals to total energy at B. So what is the total energy at A? Simple equation. Kinetic energy at A plus potential energy at A equals kinetic energy at B plus potential energy at B. Fine. At A point, 0 plus what is the potential energy? mgh. Kinetic energy at B point maximum, so kinetic energy, potential energy is 0. So can I say mgh is your kinetic energy? Clear? Now place the value and you will get the answer. So kinetic energy is equals to, what is m? 2.4 times g is 9.81 times height is 1.3. Solve it, solve it, solve it. Yes, your answer is 30.6 joule. Clear? This is your kinetic energy. Kinetic energy of the or at the base position. Clear, guys? Okay. Now let's move to the next question. Now, question number 2. A spring has a length. Okay, whenever we have the word called spring, so two things you need to focus. The one word is called force, negative kx, or which is equals to negative k x final minus x initial. Yes or no? This is for your work, force. And work done is half time kx square. Clear? So we need to use this and nothing else. A spring has a length of 15.4 centimeter hanging vertically from a support point above it. A weight of mass, this is your keyword, okay, is attached to the spring, causing it to extend to a length of, okay, to a length of 28.6 centimeter. What is the value of spring constant? Okay, now just check the values. This is your initial value, negative, not positive. This is your initial value xi, this is your final value xf. So this is in centimeter. This is in centimeter. So can I say xi is equals to negative 15.4 centimeter? So convert it. So can I say 0.154 meter? Clear? Okay. And xf is equals to negative 28.6 centimeter, which is equals to 0.286 meter, and both should be negative. Clear? So what we are looking for? We are looking for k. Can I say f is equals to negative k times of xf minus xi? Fine. Okay, solve it. So first thing, what is f? I told you m times g equals negative k. What is xf? Negative 0.286 minus bracket minus 0.154. Okay, so place the value. What is the mass? Mass is given as 0.2 multiply, what is the gravity? 9.81 equals negative k. And guys, solve the values. Negative 0.286 plus 0.154. Okay, so just put in your calculator. The value of k is equals to, yes, solve it fast. So it will become positive 1.4 or 14.9 Newton per meter. So this is your answer. Clear, guys? Fine. Okay. Now there is one more question. Let's say if the spring is going up. This is the next position. Let's say question number 2, spring is going up. So this is your negative 28.6 and now you are here at negative 24.0 centimeter. So this will become your x initial and this will become your x final. Now guys, just solve it easy, huh? So what you need to find, you just need to find the force. Okay, can I say force is equals to negative k xf minus xi? Yes or no? K, we already find it out. Yes or no? 14.9. So place it here. Negative 14.9. What is the final value? Negative 0.24. I converted this into the meter. It will become 0.24 meter. This will become your 0.286 meter. Okay. Minus minus plus, so 0.286. So your force will be, just calculate it fast. So it will become your 0.68 Newton. So this is your force. Fine. Clear? Okay. Now we have the next question, that is a spring question, and this is one of the most favorite question of mine, huh? So what you need to understand, this is seriously very interesting. Whenever you see the word called spring, so force is equals to negative k xf minus xi, and the work done is equals to half kx square. Okay, from the picture, what do you understand? Case 1, 2 and 3. Let's say the case number 1. You can see the simple spring. Simple spring. Nothing he has done. Okay, in case 2, what do you observe? We can say it is compressed, yes or no? It is compressed. Okay. In case 3, it is released again. So guys, what do you understand in these types of question? It is just like a spring compress. So what is happening from case 1 to case 2? Can I say the work done or energy is compressed? Yes or no? And energy is compressed in form of half kx square. And when it is released, the ball will get the kinetic energy, yes or no? Because if you place a ball here and when you release it, the ball will start motion. So only if you understand these things, case A, this is called normal, nothing has done. Case B, spring compressed. If the spring is compressed, then what will happen? Can I say the word is called spring energy? Spring energy stored. Focus on this word, huh? Stored. Clear? And in case C, what will happen? Spring release its energy. Spring release energy. So it is transfer from spring energy to kinetic energy. Why? The ball starts moving. Yes or no? Sure. So can I say spring energy is transferred into kinetic energy? So spring energy half k x square is equals to half mv square. Yes or no? Finish. Your question finished now. Just need to place the things and nothing else, huh? A massless spring, okay, located on a smooth horizontal surface is compressed by a force is given. Okay, so we will use force. Okay, let's say write it here. What is given here? So can I say force is equals to, what is the value of force? 63.5 Newton. Okay, the interesting thing, we know F is equals to negative kx. So can I solve this? Half k x square, can I write x multiply x? So this will value becomes your force. So it is equals to kx half mv square. So you can place half time. The value of force is now negative 63.5. Why? Because force is given and you need, there is word called negative. Fine. Okay. What is the x? Which results in a displacement of 4.35 centimeter. Okay. So your x is 4.35 centimeter. Convert, it will become 0.0435 meter. Clear? So you can place it 0.0435 equals half m. Okay, let's say find the mass also, huh? So the mass is given here, mass is given here. Yes, the mass is 0.075 kg. And what we are looking for, we need to find the velocity. So put the value of mass, mass is 0.075 v square. Put all the values in your calculator and you will get v is equals to, the value is, yes, what is the value? 6.06 meter per second. Clear? Okay, now one interesting thing, because see, I solved this question. Now the interesting thing, what you need to focus here. The word is called x. This word. Here we are using extension, compression. So in case of compression, what you need to write, this value should be negative in case of compression. Clear? So this is your velocity. Fine. Okay, so you can write approximate equals to 6.1 meter per second. Okay, now the next question is, now it's about the wind power. So we are going to solve something related to power. So we know power is equals to work done over time. Okay, energy over time, kinetic energy over time, potential energy over time, which is equals to force times velocity. Okay, now let's read the question. How much average power, okay, we need to find the power, is contained in wind blowing at this much. Okay, velocity is given. Okay, across the rotor of a large wind turbine, such as the, okay, this, which has a huge height of 135 meter, or you can say the length or the height and the radius. Okay, this is something very, very, very interesting. First, see, velocity is given, so kinetic energy. So can I say power is equals to kinetic energy divided by time? Can I say half mv square divided by time? Clear? Okay, now what we need to understand here, because the wind is given in terms, so we need to know in terms of density. In terms of density, we need to convert everything. So density is mass divided by volume. Volume is equals to area times length. So can I say mass is equals to density is rho, area, length. Now the question will come in your mind, why I'm doing all these things? Because the radius is given. If the radius is given, I need to find out. This is very, very important. Huh? If radius is given, I need to find area. Area is pi r square. So I converted the mass, and second step, what you need to know, that what is the meaning of, simply says distance. Can I say distance is equals to velocity time time? Yes or no? So can I say v times t? Okay, now just place this one and this one in your main equation. So power is equals to half, m is rho, area is, I told you, pi r square, multiply length is your velocity into time, divide by time. So time and time cancel. So what will left here? Power is equals to half density of the wind pi r square v q. Now everything we know. First thing, this is called density. Whose density? Density of wind. which is a fixed value 1.2 kg per meter cube. Okay, second thing, pi we already know, radius is 63 meter and the velocity is your 10 meter per second. Okay, place all the values. Half time rho is your 1.2, pi, okay, r square is 63 square, velocity is 10 cube. Solve it, solve it, solve it, put in your calculator. So you will get 7.48 times 10 raised to power 6 kg, or you can just kg meter square per second cube, or you can write watt. Clear? So like this you need to solve this question. Fine. Okay, next question. Simple question, huh? Very simple question. What we need to find? Accelerating a car. Okay. Returning to the example of an accelerating a car, let's assume that car, the mass. Okay, what is given here? Mass. So mass is 1550 kg. Can reach a speed of, this is the speed. Velocity is 26.8 meter per second. Okay, time is given 7.1 second. What we are looking for? Power. Okay guys, now a very simple way how you are going to solve the power. Can I say power is equals to, because velocity is there, can I say word is called motion? Motion means velocity. Okay, so can I say kinetic energy divided by time, half mv square divided by time. Place the values. Half mass is given 1550. Okay, velocity is 26.8 square divided by, what is the time? 7.1. Okay, solve it, solve it, solve it fast. So the answer is 78.4 times 10 raised to power 3 watt. Clear? Fine, easy. Okay. This is the last question and this is one of the favorite question. Okay, now just focus on this. Before going to explain this question, I want to ask you something. Just think and then give me the answer. If you are able to give this answer, it means question is finished for you. Let's say there is a body. I am applying a force of 15 Newton. So where the body is going? Yes, of course, this side. Now I need to balance this. Case 1. Where the body is going? Left. Yes or no? This side no force. This side 0 Newton. Fine. Case number 2. If I apply 15, then what will happen? The body will be balanced. Yes or no? Okay. Case number 3. Now just take the same question. This is the body 1. Here is the 15. Now I want to go this side, right side, with the same value. Same value means if I apply 15, no force, it will not move. If I again add 15, then what is the net value? Net value, tell me fast. Net value is 15 towards right. Yes or no? Sure. So how much I apply to move in opposite direction? See, case 1, it is moving in the left. Clear? Okay, if I apply only 15, it is balanced. But if I need to move in the opposite direction, again, moving in opposite direction with same value, it means I need to apply 2 times of the value. See, when the body is going this side 15, now I want to go this side, right side, so 15 plus 15, so what is the net value? 15 towards right. Clear? Okay, now you can understand this question. A bicyclist cost, okay, angle is given. Okay, now I will tell you something, something very important to understand. Guys, whenever body is going horizontally, body is going horizontally or body is going vertically. So this is something very important you need to understand. Whenever body is going horizontally, you need to use cos theta, and whenever the body is going vertically, sine theta. Fine. Okay, let's read the question. The question is given, angle is given, theta is 4.2 degree, slopey at a speed of 5.1 meter per second. So velocity is 5.1 meter per second. Assuming a total mass. So the mass is 82.2 kg. Okay. Bicycle push rider. What power output? This is very, very important. Must the cyclist extend to pedal up the same slope at the same speed? Means what is happening? Now just try to understand. This is your cyclist who is going like this. Okay. There is an angle theta. What is happening here? The one force is going down, let's say F. So if you need to move with the same force, you need to apply, if you apply only F, what will happen? The body will be balanced, and you apply one more. So what is the total value? 2F. Then you can go with the same speed. Is it fine? Clear? Okay. Now just you need to find the power. Simple equation. Power is equals to. Power is equals to. So what you are going to apply? See guys, you have the velocity, you have the mass, you have the angle theta. Think. You have number of equations. You have in terms of, you can say, simple say, we know force times velocity. Yes or no? Okay. Body is going up. Can I say sine theta? So what is this? Can I say this is called net force? Net force applied. Yes or no? Okay, solve it. So power is equals to, what is the net force? 2F. Clear? Velocity sine of theta. So 2 times, what is the applied force? Force means m times g. So what is the mass? 82.2. Okay, what is the gravity? 9.8. Multiply. Okay, what is the velocity? 5.1. And what is the sine of 4.2 degree? Solve this, solve this, solve this. So power is equals to, you will get 602. 602.3 watt. Clear? Fine. So you understand the concept of 2. This is very important. Why 2F? Why it is a 2F net force? Because if you want to go up with the same speed, you have to apply 2 times. That's why it is one of the very, very, very important question, and this will 100% come in your exam also. Clear guys? So now I hope that you understand all the concepts and you can do in a very good way in your exam. Okay. So guys, till then, take care. Bye.